This lesson is going to be all about finding area of regular polygons. So far we've had some formulas already given to us for parallelograms, for squares, for rectangles, for trapezoids, for circles, that kind of thing. So I want to go through what regular polygons would be. Now, if you recall from previous units, a regular polygon has all congruent sides and all congruent angles. So we're dealing with everything's the same instead of random angle measures and random side lengths. So in a regular polygon, a segment drawn from the center of the polygon perpendicular to the side of a polygon is called the apothem. So that segment that you see going from point P at the center of the polygon to point S at the side, that is called an apothem. So we use the lowercase letter a for this. And our formula for the area of a regular polygon is 1/2 the perimeter times the apothem. Okay, so one other thing, just as a quick aside, file this to the back of your brain for the next lesson on geometric probability. The area of a circle is pi r squared. Our r being from C to B here, that's the radius. So pi times radius squared. Kind of deal with a similar thing in a sense with the apothem, but this, for radius, we're dealing with circles. For the apothem, we're dealing with a polygon, so no circles. So if we take a look at this problem, now, this problem already has the answers listed, but we're going to show how to actually get there. We're going to use, we know the area formula for a square. We could make this really easy. However, we want to get that practice in for our new formula, right? So we want to use 1/2 times perimeter times apothem, right? Now, one side of our square is 26, which means we know that every side is 26. So to find that perimeter, we do 26 times 4, we get the 104 that you see listed. To find the apothem, this is pretty straightforward because we know that this segment here is 1/2 of one side of the circle, so that's pretty straightforward that it would be 13. So here's that answer, right? Some shapes, it doesn't work out as easily, okay? So there might be some extra work that we have to do. So now, if we plug in our information, we have 1/2 times 104 times 13. So 1/2 times 104 times 13 gives us the 676 that you see. Okay. So let's try a shape that we don't know a different formula for. Let's take a look at a hexagon. When it comes to a hexagon, and we want to find the area, again, our answer is kind of given there to us. We already have the apothem here. That one's given to us already. And we need to find the perimeter in order to go any further. So the nice part is, when it comes to something like a hexagon or a regular polygon, we can create all these triangles. Let me change my color here. All these triangles right in here, right? Now a hexagon has 1, 2, 3, 4, 5, 6 triangles, okay? Now, we know from circles that the central angles add up to 360. So we're going to actually take that little tidbit and we're going to take 360 and divide it by the number of triangles that we have here. So 360 divided by 6 is going to give us 60. That's the angle measure for a central angle in a hexagon. So we're saying like one of these angles is 60, this one is 60, this one is 60. We can keep going, right? Everybody's 60 at this point. So if we wanted to focus on this triangle right here that involves our apothem, I'm going to draw that up here. That's half of one of our central angles. So while the side is 3 root 3, the bottom here is 90. This angle up here is 30, which means we're dealing with a 30, 60, 90 triangle. So to go from long side to short side, right, we're taking 3 square root of 3, dividing that by the square root of 3. Woohoo, we get 3. No radical involved. So that's only half of one side. So if that half is 3, then that means the whole thing is 6. We've got 6 sides that measure 6 units, so our perimeter is 6 times 6, which is 36. And then we take our area formula for a regular polygon, and we have half times 36 times 3 root 3, right? Half of 36 is 18. 18 times 3 is going to give you 54, and we're going to leave the root 3 completely alone. No decimals needed. And that's pretty much what you do. Now, the main focus on our areas for regular polygons is going to be a hexagon. So you already know what your triangle looks like. You're able to find the apothem using the hypotenuse of our small triangle, right? This section here. You're able to find the 1/2 of one side using the apothem. You're actually able to also find the apothem, right, from any of those. So you have to remember your 30, 60, 90 triangles as far as hexagons are concerned, so that way you can use your area formula.